Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hey everybody, Brian Benz here, Cloud Advocate at Microsoft. Today I'm going to talk to you about ACA dynamic sessions for Java, and we're going to use LangChain4j. I've got some slides here. I'm going to go through those as quickly as possible. We're going to get to demos, which is most of the session. I'm going to show you what ACA dynamic sessions are. I'm going to show you a little bit about LangChain4j and building tools for LangChain4j, and then I'm going to talk about a specific example that I've created for LangChain4j for connecting to ACA dynamic sessions. You can find me on most of the socials and GitHub at bbenz, including the repo that I've created here. And I have a short link for the repo, which is aka.ms/ACA on L4J, because it kind of rhymed. I like that link. So everything, basically there's an overview of the session and a link to the actual code and some slides. All right, so first of all, Azure Container Apps. What the heck are they? Azure Container Apps are basically, if you think of a big Kubernetes cluster, you can actually create a Kubernetes cluster yourself and then run all the code I'm going to show you today on top of that cluster. Or you could just go to Azure Container Apps and you basically grab a node of a huge cluster that's already running and just run your code on that. You only use it for the moments you're using it. You only pay for the moments you're using it. And it's shut down based on some parameters after you finish using it. ACA Dynamic Sessions runs on top of that. And basically, there are two ways to use it. There's a Python interpreter and a custom container. The Python interpreter is what I'm going to show you today and focus on. These are temporary environments that run on top of ACA. And if you need isolation and quick startup performance, let's say you're running an agent and it's generated some code and you want to try that code, but you want to try it in a safe environment. That's the primary use case. There are other use cases as well, but the whole idea is you can take files, take code, put them in an environment that is safe. It's not on your machine. It's not exposed to anything else unless you want it to be. And you can test it, run it before you actually use it in a more permanent environment. Sample user scenarios would be like AI chats. You can create chats. I'll show you examples of that today. You can test out your prompts on a variety of different large language models on the back end. You can just do transient processing. So just try code, see if it works and see if it's harmful. Grabbing some code from a third party, of course, can be risky. So you can actually try it out and test it, maybe run some security tools on it inside of a container app session. And then next, you can do remote builds or cloud shells as well. So there's two components to ACA dynamic sessions. There's a session pool and there's sessions. So when you set it up on Azure, you actually set up a session pool. And from there, you call sessions, and you can run as many sessions as you like. That's one of the main features of this as well. Aside from safety, scalability. So it's easy enough to run a demo agent like I'm going to show you today with one user. What about if you have 100,000 users running agents all the time, and you need to have that execution and that scalability? Well, that's what the session pool comes in for, and that's what you can actually use it for. So there's some session pool settings, the max number of sessions. So just making sure that you keep a lid on how many sessions can actually run. And then there's a cooldown period. And the cooldown period keeps your state for that period of time. You can also put some secrets pre-created and added to your session pools as well. And the cool thing about the cooldown period is the state is actually preserved. So the session itself represents an execution, not a resource type. So the execution is single use. You run your code, in this case, the Python interpreter, to do things and ask questions of an AI. And then you invoke an API for each execution. And you can preserve state between executions. So you could call an execution, you generate a token, and you can use that token to go back and retrieve things. So let's say, for example, you've got a file, you create a file, you want to test that file in a safe environment, you put that file up into an ACA dynamic session, and then from there, you manage everything you want to manage within that session, and then you can call it from you can call it from Java, and then later you can call it from Python, and you'll still be able to access it as long as you have access to that API. The state and the files and everything will still be there, and you can still use them. So here's a little bit of sample code. This is in general. It's adapted for each language, of course, but for a post, where you're actually just asking questions of a chatbot, for example, there's a link that you send things to, and then you send these properties in the body, the execution type, the Python code you want to send, for example, the timeout that you want to send as well. And then session invocation and authentication. Basically, you get a token. You create a Azure Container Apps session using a session creator, and then you have a specific URL and link that you use for your session pool, and you use the token that you've generated to authenticate with that session. And then if you want to upload a file, this is the sample for that. So you post again, but this time you're posting to upload file identifier. You just send something there and basically just send the file in binary. And then a list, you just basically get a list of the files or whatever you've got running in that session pool, that session. And then you can download files from a specific session as well using the download file identifier. And that essentially is the overview of ACA dynamic sessions. And by the way, if there are any questions about any of this, please do jump in. I'm going to go into the demo now. So 10 minutes of slides. Hopefully that wasn't too painful. Hopefully it gave a good overview. Actually, let's go into the so this is what I've got in the portal. I've already created this at portal.azure.com. If you don't have an account, you can actually create one for free at portal.azure.com, and you can sign up. The thing I've got here is what's called a resource group. So the resource group contains different objects that you've got and you're going to be working with, organized in a single place. So in this case, we've got an Azure OpenAI instance. It's running in Canada East, and we've got a session pool for Azure Container Apps running in West US 2. If we drill down into that a little bit, the session pool itself, you get an endpoint basically, and that endpoint is how you interact with that session pool. And you do need a token and API access to do that. Then from there, you can click on Playground, and inside the Playground, you can interact with this particular session. You can get session information. What you do is you actually have an identifier. It'll generate one if you don't have one already, and you can just send things to that. You can also manage files from here as well. So it's got a nice little interactive portal environment that you can use. You can configure this and check out all your different sessions and what's inside of them from the portal. You can also do that programmatically, which I'm going to show you in a minute. Inside of there as well, I had the OpenAI session. So if we go back to the resource group, that was the session pool. Here's the OpenAI session. Inside of there, basically, you go to the Azure AI Foundry portal. There are endpoints that you can use to access this, and that's what I've got in my code. And you can also manage keys to access this too. If you go into the playground here, you can see my deployment that I've set up. In this case, I've just got GPT-3.5 Turbo, which is getting kind of old, but it still does a job for this demo. It's really simple and it's cheap and it's quick. So that's why I use it. Here at Microsoft, we are limited on the resources we can use. Those, customers come first and they get to use our AI resources, which are in short supply. So I always have to pick something I know is going to work for sure when I'm creating these resources. And I picked the GPT-3.5 just because I'm asking the basic questions that doesn't need the latest info or the latest processing capabilities. And so this is the best way to go. There's all kinds of other models you can choose from inside of the AI Foundry, which is where we are now. You can see all the different models. You can play around with all the GPT-4.1, which is brand new. You can also have different models here. And we have, let's see, I've only got 35 here for this particular case, but, and that's for inference tasks with fine tuning. But I believe there's like 1,900 models right now that you can choose from. And we keep that up to date constantly. You can go into any one of these models and when you look at them here, you can see a little bit of information about, see more, about the model itself, and there are usually benchmarks here, but I don't see any here. Maybe because this is so new. Let's go to an older model. Let's see, GPT-4.0 should be okay. Existing employment license. Usually you have some, so there's some benchmarks here, which are nice. It gives you an idea of what you can choose. And there are ways to select and compare models in the benchmarks. I'm not going to go to that right now because I just want to show you a little basics of the different models you can choose. But in this case, all I've got is my deployments down here. And it's just the GPT-3.5 Turbo. And once I've got that, I've got some endpoints and some keys that I can use and access this. And I've also got some nice information here about basically about accessing the model with different languages. I can choose Java. I can use the Azure Inference SDK or the OpenAI SDK. For this one, because it's OpenAI, it's probably easier to use the OpenAI SDK. And we also have different authentication types. So Enter IDs are user-based and organizational-based authentication, or you can just use the endpoint and key, which I've used in my code. All right, so once I've got that endpoint and key, and I've checked out a few different examples here, then I go ahead and write the code. Over here, I've got the code in Visual Studio Code. Let's see, what should I do? I'm going to actually run this first and just show you what the code does. And then I'm going to show you how it actually does it by diving into the code itself. So we're using LangChain4j to access this. And I've got a sample here. The sample code is in LangChain4j examples. And then from there, it calls LangChain4j directly to process a piece of code that I've added to use LangChain4j to process Azure ACA dynamic sessions. Let's run that. Let's have a look at this. So I just go Maven exec Java. I've already built it. Takes a second. There we go. So it's going to execute this. It uses Netty as a transport to go to OpenAI and Azure Container Apps. And it does a bunch of stuff. So let's show you what it did first of all. Basically, I asked it a question. If a pizza has a radius Z and a depth A, what's its volume? The volume of pizza can be calculated. So it went out to it's running on top of my Azure Container Apps, and it's accessing my GPT-3.5 via the OpenAI service. It's got the endpoints and the keys all set up and ready to go. So I ask a question, I get an answer back. If the volume of pizza can be calculated using the formula, and it gives me a nice little formula here. And then it generates some Python code because it's a Python code interpreter. It actually generates some Python code to tell you how to actually calculate the volume of a pizza. And then what we've got is over here in my examples, I've got a Hello World Java file, and I basically ask it to upload that file. There's a little bit of stuff here. It says it found environment credential is unavailable. So this looks like an error, but it's not. It's info. And what happens is I wanted to show you this in the sample code because this is how the Azure Credential Manager manages all the different credentials. And these are the options you can have. So first it checks for Azure Identity. Next, it checks for, two different things, an environmental credential in the Azure Identity. Then it checks for a workload identity credential. It says it's unavailable. That's okay. Way down here, we do have something that was available. So it tests all the different things to see if it can access that Azure Container App using a token that is generated. And the next one is its managed identity credential is unavailable. Shared token credential is unavailable. IntelliJ credential is unavailable. But look at this. Azure CLI credential returns a token because we're running in the Azure CLI here. In the command line interface, it actually generated a token for me in Java, and then it uses that token. It uploads the file. So this is all these ones are unsuccessful attempts at authentication. So you can see it's secure, and it figured out, it iterated through all the different options it has for securing the connection, and finally picked one. And it was able to upload the file here. And this is the link to the Azure Container Apps session. If I go, this is the token identifier here. So let's go back to just to prove it worked. It generated that token randomly. Let's go to our playground here. Let's paste in this credential, and let's go to, I have to hit enter because the UI is a little iffy. And then I go to manage files, and hopefully, oh no, what happened? It's not there. What happened? It should be there. Hold on. Live demos, folks. Did I type this in wrong? No, it's there. Did I get the right token? Hold on. Let me make sure. Okay. Files, downloading. Okay. Let's use this identifier instead. Maybe because one of the things about my code, and I'll explain it in a minute, is it actually uses a different token for every single one of those processes that I've got there. Let's hit enter, manage files. Hey, there we go. So Hello World Java is there. Okay, so it uploaded that to a session, but that session was shut down. And then it created a new session for the download and found the file there. So Hello World Java is there. And let me show you how that worked. Okay, so first you upload the file to a specific token, and then you say file uploaded successfully from the local path, Hello World Java, and it shows the size in bytes. And then it downloads the file. It uses a different token for that. So the other token was kind of wiped out. Once you've got the new token, you're still sharing session information at this URL, but the new token is actually the one you want to use for authentication. And then it downloaded the file, and it says file not found, but that's because we've got a new token and the file was in the old token. long story. But the right way to do this, I wanted to show you this fully in a demo because I wanted each of these downloads to be self-contained. But in the real world, what you would do is generate a token at the top of all of this, and then use the same token all the way through. That way it would be able to find the file. But it did actually list the file, and I showed you there where it was, and it wasn't able to download it because couldn't find it with the different token. So it shows you the authentication works, shows you that the session tokens work, but in the real world, you want to have a shared token that works between all of them. All right. So at that point, we're 20 minutes in. I don't know if we have any questions. I did want this to be interactive, so please do jump in if you have any questions. I'm going to go through the code now and just show you what the actual code does. But if there are any, I'm keeping an eye on the comments here. So far, thank you, Danielle, for saying this is fun. I appreciate it. Kind of a niche topic, running agents on Java using LangChain4j. Yeah, hopefully this is a useful thing. It's really cool stuff, and I'm able to do this really quickly. So let's dive into the code. So in this case, I'm using a tool that I created on LangChain4j, and I'm accessing it using this file. So I'm able to have a fairly short file here. Most of it's comments, and I'll get into the comments in a second. But basically, the file itself just does a couple of things to interact, and it does an upload and a download, as you saw in the running code. So let's start with the packages. So we use LangChain4j. We use a tool that I'll get into in a minute. That's over here, the LangChain Sessions Java Repl tool. We use a memory for chat. And then we have a chat language model, a Azure OpenAI chat model. Also an AI service and a dynamic sessions. This is actually where we call the actual tool that we wrote custom for ACA dynamic sessions. Everything else here is provided by LangChain4j, so it provides a lot of the underlying code for interacting with tools, interacting with chat using memory, interacting with Azure OpenAI, and interacting with the Azure AI services as well. And then we just got some basic Java packages here, the IO and managing the files, and using base64 for downloading the file as well. Okay, so the comment here is pretty extensive. These are the environment variables that you need, and I've already preset these. So you have a pool management endpoint, an Azure OpenAI API key, and then the Azure OpenAI endpoint and the deployment name. Then you've got a region. In this case, we're using, I'll show you in a second what these are. Subscription ID, resource group, session pool name, session pool resource ID, and the CLI username. So the CLI username is mine. That's what's used to generate that token that accesses everything. All right. So let's go back into the actual thing here. So this is the resource group. It's called BBenz ACADS. And then we have the session pool called My Session Pool. We use this endpoint, and there's some keys that, of course, I'm not going to show you, but those get accessed as well. And you also generate a token every time you access the session pool with that link. And then we've got the session pool playground. This is just where you test things. But the OpenAI session, the service, the endpoints and keys are here. And you can also get them from the AI Foundry up in the overview as well. So if you go into the deployments, GP335 Turbo again, there's the URI and key that you can use. So there's different places you can get it. But basically, that's how we access that code. So the pool management endpoint, the API key, everything else is provided when you do the setup. And that's part of the instructions that I've got at ACA for L4J link that I'll show you at the end again. All right. And then you got the export. So the first thing we do is we just set up a chat using the user message. Retrieve the pool management endpoint from the environment variables. So we have to actually call that. We have to be authenticated for that to be able to generate a token. And then we call the sessions repl tool, new sessions repl tool. So that tool is over here in LangChain4j. And we'll dive into that real quick. So inside of LangChain4j, we've created a tool basically. And once again, it's got several Azure imports and a few imports for working with HTTP and JSON. And the repl tool itself, we designed it as a LangChain4j tool. And the reason for doing that is basically the tools versus other options are really good for execution of a single shot sort of application that you need to build. They're really good for function calling, parameter handling, state management, and of course, it's Java integration as well. It allows you to have different options for authentication and for handling parameters, which are ideally suited for LLMs, including authentication, chat models, and things like that. So LangChain4j has created this tool functionality that allows you to do that. It's a component of LangChain4j. And we identify it as a tool, and you use the pool management endpoint. You generate a random ID, and you send it to a string and clean it up so it's actually going to work with the ACA dynamic sessions. And we'll dive back into this code in a minute, but let's go back to the example. So what it does is it calls that tool for us. Then we use the Azure API key to get it from the environment variables. And it checks, it stops execution if you don't have that. And then we have the OpenAI endpoint, once again, stops if it's not there. And then we check for the deployment name, GPT-3.5 Turbo in this case. And then the chat language model, we do a builder for that. So this is a LangChain4j chat language model for OpenAI inside of LangChain4j. You use the API key, the endpoint, the deployment name, and then you have the AI services builder. This is the one that actually asks the question. And this is the question here. And you send a question to the OpenAI model versus the ACA via the ACA dynamic session, and it gets an answer back for you. And then basically you print the question and the answer. And the next thing we do is upload that local file. So we're going to grab this file from here, Hello World Java. It's provided in LangChain4j examples. And we call the tool to do a uploader. The sessions repl tool uploads the file to the local file path, and then it gets the file name. So now we can go into the repl tool, and I'll show you what this does. Let's see here, down here. So this is where the actual upload happens. It takes the, let's see, getting lost in my own code here. Okay, so we get the token. So this is just some processing that starts the tool itself, gets the response for the chat, and then has the tool value there. The next thing we want to do is, where's the uploader? Just a moment. So this actually executes the code I just showed you with the chat. There we go. So upload. So the first part is it actually generates the chat. So and the chat can handle chats from any model that I showed you there. It doesn't have to be OpenAI. It could be any model. And LangChain4j handles all of that basically and returns a response for you. So once again, this code is actually in LangChain4j. And this code is in another repo called LangChain4j-examples. That's the example code. So we're calling the uploader. This is the uploader interface. We get the class myFileUploader, and then we grab the local file path in this case, and if we find the file, we get it. Otherwise, we exit out of here. And you have the access token for actually uploading the file. You pass the URL into this string, and then it builds the URL that you need using the files upload command. If you remember those post commands that I showed you in the slides, this is the interpretation of that in Java. And then it uploads the file and uses the HTTP client, the OK HTTP client, to do that. Uses the local file and passes the multi-part body to the, basically streams it up to the ACA dynamic session. And if everything's okay, it will list that file and give you a response back with the name of the file and the number of bytes that are in there. So otherwise it throws this exception and fails to upload the file and basically stops there. Okay. So the next thing we do is we download the file. Let's see. Just checking for questions. Greetings, Abdul Razek. Hope I'm getting that name right, from Alexander. I've been there, by the way. Great place. Anyway, well, I digress. Welcome. The next thing we do is now we've uploaded the file, we download a file. So the file downloader, we grab the file for this. So the sessions example grabs the local stuff, passes it to the sessions Java repl tool over here. And this is the download. So the download file is very similar to the upload. It gets the string. In this case, it builds a URL instead of building it with the, where is it? Files upload identifier. It actually uses the files content identifier, because we're actually going to find the file first and then download it. Starts the new OK HTTP client. So once again, it independently runs from all the others and checks to see if the token's valid. Then it checks for the remote file path. If it's there, it starts the process. Otherwise, it gives you a 404, file not found. And next, you use the bytes for base64 encoder to download the file and store it on the local machine if you want to, or just if it can't find it, it will say failed to download file, or it doesn't have access to the ACI dynamic sessions for whatever reason. It throws this exception. All right, next is list. So we want to check what's inside of a token. So list here. Sessions repl tool, my file listener, and then file list, lists files, and then system out print line. Basically just lists the files. If it can't list the files for any reason, it just gives you an error. And that's basically it for the example. Let's see, in here, the list. So we use the access token again. We use the URL to pass it. We use the HTTP client. We request a new builder. And then we basically iterate through all the files that are in there, create a response as a JSON object, because it could be more than one file in there. And then from there, we use a JSON array, download the file, and pass a string to the response. So that's what you're seeing down here. And of course, if it fails, it'll say fail to list files for whatever reason, authentication, can't find any files, et cetera, et cetera. So that's this in action. So hello world Java, we found that file. So first of all, it asks the question, We found the file, we uploaded the file, and we confirmed that the file was uploaded here. File uploaded successfully from local path, and it's Hello World Java, 128 bytes. And then we download the file, and it did download it, and it lists the file Hello World Java, even though it says file not found. It's because it's in a different session. That's basically, boy, it's 12:35, and I've kind of gone through this. I was hoping to get some questions. But I can talk about pretty much anything at this point. I'm kind of went through there rather quickly. Oh, I guess I'll go through the POMs. So there's a couple different POMs for this. Let's go with the example POM first. This is the example. So in this case, I'm calling it dev, the project coordinates are dev LangChain4j examples, and the artifact ID, ACA dynamic sessions examples, and from there, okay, so Frederick was asking, I'm just looking here, at the end, will you please post the GitHub URL? Absolutely, for the code. And please include a commit with docs on the environment setup. Okay, yeah, I'm happy to do that. Basically, you just, I'll go through the instructions in a minute here for that. That's a good point. I can actually show you how to set these up through the portal or through the CLI as well. But we set this up for Java 21, and then you have a few dependencies here. Of course, you have LangChain4j, and that'll pull in the main LangChain4j code, and it inherits the project version from whatever version you have running. In this case, my local machine, we got beta 1 or 103. I can't remember exactly. Oh, there it is. 10 beta 1. That's the one I've got right now. But in this case, it inherits it. This was the hardest part, by the way, of building this code, is setting up the dependencies properly. When you're working with LangChain4j, and this is not a bad thing, but it's a moving target. So LangChain4j is updated daily. And that means that the version numbers of certain things are updated daily as well. So keeping up is a real challenge. If I leave my code for a week and come back, I've got to redo the POM. I've got a few things I have to fix. Generally, there's lots of things that happen and change. So, and it's not a bad thing. It's evolving. So, but you do have to keep up. In this case, we inherit LangChain4j Azure ACA dynamic sessions. And that, I'll show you in a minute what that is. And then we have a couple of Azure Identity SDKs. So you saw that for iteration with the info that's going through all the different credentials. That's using the Azure Identity SDK. And we're using Azure Core as well to access some of the things there and access our OpenAI services and the ACA dynamic sessions. And then we have log4j. That doesn't change very much. The version might. And then, we've got the Google code JSON. I think that must be left over. I don't think we need that. I think I was probably playing around with something. And then the build configuration. That is at org Apache Maven plugins. So basically what we do, we have a different POM for runtime and a different POM for build, and we use the Maven compiler to actually build. It just makes things a little simpler in terms of what we're going to manage. And we specify a specific Maven plugin. I think the version that's current is 3.9.9. We're still using 3.1, but it works well. So so that's basically the examples pom.xml. So that's over here, the pom.xml for examples. But then if you go into the pom.xml for LangChain4j, ACA dynamic sessions specifically. So of course, LangChain4j has their own POM. LangChain4j ACA dynamic sessions is an additional POM that we put under the directory Azure ACA dynamic sessions. So you're asking about the GitHub link. If you just go to LangChain4j, you'll see the Azure ACA dynamic sessions directory. And by the way, this changes all the time. So you might be watching this recording later. Definitely check this out. They will always be in the same place, but of course, these are probably going to be different. But I'll show you what they're like right now in case there's any need to do that. Dev LangChain4j, we use the parent. So the parent for that is, I'll get into that in a minute. I think we have time to cover that. So I'll actually explain that a little bit in a bit. So the project coordinates, in this case, LangChain4j, but our artifact ID in this case is called LangChain4j Azure ACA Dynamic Sessions. And the project itself is there. And I'll open that in a second. I'll show you what that is. So, and we have a license, and then there is a setting here for LangChain4j core. So we include that. We include OK HTTP3 so we can interact with the chat model and the other upload, I believe. And then we have JSON. We're going to manage the JSON because when we create a list of the objects in the ACA dynamic session, we return it as a JSON object. And then we, of course, have Azure AI, OpenAI. We're using that for our chat model. And then Azure Identity, once again, is used for iterating through all those different connections. And LangChain4j, Azure OpenAI. Now, keep in mind, some of these look redundant, but in the examples, this is just an example that's written to use the tool. When you're running the tool by itself, you can write any kind of code to execute against it. So you do need to have sort of redundant things in here like Azure Identity and Azure OpenAI and a few others. So we're using Jackson in this particular case for data binding. And then we have a Reactor Core and Azure Core for connecting to Azure and using different functions inside of Azure. For example, token generation, I believe. And then LangChain4j core, of course, LangChain4j. These are in here as well. So these are used when you're actually building the project. And they're used at runtime through either the example POM or the POM from here. So yeah, let's go ahead. I'm going to do a new window. And I'm going to open LangChain4j so I can explain what that does. File, open recent. Do I have? Yeah, I have LangChain4j there. So basically, inside of LangChain4j, you've got your core code, you've got your docs, and you've got a main pom.xml here. This is the LangChain4j pom.xml. So let me make this bigger. Not that big. There we go. So basically, when you're looking at my example, this is the tool, the pom.xml for the LangChain4j dynamic sessions. And you can see here that we have a parent. Where's the parent? LangChain4j parent here. That pulls in this pom.xml. And this pom.xml, a little smaller, is used, and it's quite extensive for pulling in all the latest stuff from LangChain4j. I might have a slightly older version of this here. Yeah, I've got 1.0.0 beta 1, so I think it's at 103 now, but like I say, it changes daily. So I'm keeping it this version right now because everything works. I'm probably going to have to update it before I do the next pull request out to LangChain4j. So it might not be immediately after this session, but it will be shortly after the session. I'll have to make sure everything works first before I publish it. Not because the code's bad, it's just because it changes the POM and everything inside of LangChain4j changes all the time. So this is our LangChain4j Azure ACA dynamic sessions. This is my contribution. This is the pom.xml that is then pulled into the main pom.xml. And this is the main one. Oh, yeah. Okay. Sorry. I clicked on the wrong one. This is my POM. I was showing you the same thing. This is the main LangChain4j POM, and it's just got a ton of different modules. As you can see here, my module, I think, is here. Yeah, model providers. So we've got different providers. And this is the advantage of LangChain4j, by the way. You've got different model providers that you can use, and these have all been contributed by the source, for example, Anthropic, Azure OpenAI, Bedrock, Cohere, Hugging Face, et cetera, et cetera. You get the idea. So all the different models here can be pulled in. The embedding stores, we've got those for Azure AI Search, Cosmos DB, Cassandra, Chroma, et cetera, et cetera. And then we've got document loaders, in this case, Amazon S3, Azure Storage Blobs, et cetera, et cetera. Document parsers, transformers, code execution engines, and where's mine? I don't know. Don't see it there yet, but it's here somewhere. And then we've got the actual POM.xml, which builds everything. And there's several different parts of this, including Open Rewrite, Java docs, and a few other things that basically get generated when you build this whole POM.xml. So my workflow for this is to basically, and let's go into the different things you've got here, actually, before I talk about my workflow. There's the LangChain4j, which is the main source. And there's different components of that. But then there's also the contributions, which is Anthropic, mine, Azure ACI Dynamic Sessions, AI Search, Cosmos DB, et cetera, et cetera, et cetera. And these are all pulled in using those POM embedding stores, et cetera, when you do that. So the different modules are identified here. And mine must be there. I just overlooked it. Okay, anyway, it has to be there for the whole thing to build. And basically what I did is I came in here and then I actually built this. So it's in my local M2 cache. So I did a Azure build, and there's a formatter that you need to use as well. But anyway, you can just do a Maven build and it puts it in your M2 cache. And then I went over to my example here, wrote the code, and then did a Maven build and then Maven execute Java inside of here, and then went ahead and debugged it. So you can add things and you can contribute to different things in LangChain4j, and that's actually how you do it. The next thing I did, let's see, what can I go into here? I can go into how I actually created this stuff, but I have some keys and things in there. I can't really show you everything. Unfortunately, I do have a script for actually generating all this stuff, but it has keys and things already built into it. So I can't really show you that too much. Let's see, we've got a few more minutes. There's a question here, is Maven preferred over Gradle? Not necessarily. LangChain4j uses Maven. So we're using Maven. I personally don't have a preference. I could use either one. But for example, Spring and Spring AI tend to prefer Gradle. I'm not sure it's a preference. It just tend to use Gradle. And then LangChain4j tends to use Maven. I do like Maven for being able to have Maven Central, which allows you to pull in different components as dependencies easily. And by the way, being able to use the new agent capabilities is huge. This has saved me so much time. Let's go into that's a good demo I can show you. This is more valuable than actually showing you how to set this up. The setup is actually all in the description at, where is it here? It's here at aka.ms/ACA on L4J. There's a description there on how it's actually set up. And actually, now that I think about it, I'll set up a genericized version of the script that I used to generate all of this as well, because I had to do that yesterday. It's a different reason for doing that, but you don't need to know why. It was I had to recreate everything last minute yesterday. Of course, that's the way it goes before you do a big presentation. So so let's go in here and let's look at, this is my example POM, and I can say, let's go into our GitHub Copilot, and I'm going to ask actually, what I'll do is I'll probably, yeah, let's just ask, is there anything I can do to improve or update this POM? This is a lifesaver. 6 months ago, I couldn't do this. And so I would have to go through my pom.xml if it wasn't working correctly and find out what exactly were the dependencies that have been updated and which ones have been deprecated, and just manually figure out each one by going to Maven Central and searching for things. But now I could do this. I could just ask it. And if you notice, it used my context for the pom.xml. I have different options for asking. I can do ask, edit, or agent. I'm just asking right now because I don't want it to actually change any code. But if I do, look at this. This is the latest. So there's some in here I didn't even know about yet that just were added. Gemini 2.5 Pro was just added. I know that for sure. GPT-4.1 was just added. But I can choose any one of these models and ask a question. And if I go into edit mode over here, it will actually change the pom.xml and ask me if I want to keep the changes. In this case, I don't want to do that right now because just for during the presentation. But let's see. So it looks at the pom.xml. It checks the dependencies. It also checks the dependencies on the LangChain4j POM, and it checks Maven Central, a few other things. And then it tells you remove duplicate overlapping dependencies. I bet it's going to call out that Google dependency. And then the log4j to update log4j to address vulnerabilities. Yeah, specific optimizations, add an Azure SDK bomb. Okay, I could do that. You don't have to. But here's an updated POM. So it actually gives you the updated POM. And let's see what it did. I could actually compare this to the old version. And I can see what was changed. So let's do that. Let's go in here. Right now, what have I got in my changes? Copilot instructions. Okay, that's not necessary. But I can actually go in here and I can make changes here. Very brave to be doing this, but okay. If I save this, I can undo it later. And then I could go in here and I can check my POM to see what it changed. Now you can do this with edits. So edits will actually tell you what it's changing as well. This, there's ask, edits, and agent, but edits will actually tell you what it's changing. But this is another way to do that as well. So let's just close this for now. Now I can see what it did. So it gave me, okay. Let's get rid of that. Move this over a little bit more. So it added this whole section for building. This is actually wrong. So it did something not so good here. I've done down this road before. So it wanted me to do a build with this project. And the dependency management, it actually added an Azure SDK bomb as it recommended. I prefer to have the individual dependencies pulled in because later on you have to update a single dependency rather than a whole bunch of them at once. And then the LangChain4j version, see, that's wrong. You need the project version number there. So it didn't really do everything so great in this particular case. But sometimes when you ask it, it really does say, oh, there's your problem right there. This dependency needs to be updated. You update the dependency and you move on. And so that might have taken anywhere from 10 minutes to an hour in the past to figure out which dependency is wrong and update the dependency. And by wrong, I mean out of date or deprecated or something like that. Let's see what else it did. So LangChain4j version. Yeah, so this one it did right. So in this case, I'm specifying the version, but really you want to pull the LangChain4j version from your LangChain4j that's running locally and use it there. And let's see what else it did here. Okay, it's made a lot of additions here. Okay. And this won't actually build, I can tell already. LangChain4j OpenAI, LangChain4j version. The identity SDK, now the version is managed by BOM, but as I mentioned, I don't like that because you sometimes have to update one particular version, and it's not good to do that this way. So this is good. Not only am I showing you the capabilities, and by the way, it is, I'm still going to say it's a good thing, but sometimes this is where experience comes into value. So you need to know what's good and what's not based on coding and making mistakes and fixing things. So will AI replace a developer? Maybe. If you're a junior developer, you've never done this before, you can get in a lot of trouble. But you do have to have some experience to be able to know if it's leading you astray or not. In this case, this would work. So you could have a dependency, you get the version, but the version is just, in my opinion, better to be put in here so that later on, if you ask Copilot again, which versions need to be updated, it can do it properly without having to refer to these. This is kind of a pain. So on the right here is what's been updated, and the left is what they deleted. So here you can see what the version is. Here you can't see what the version is. You have to go back up here to see what it used for the version. I don't like that. I like to just be able to look at this and update the version. I guess this would be handy if you know what version you're supposed to use at the top and just change them. But I prefer not to do that. I prefer to have them in each value. So in this case, I would just discard the changes and keep what we had and get rid of that. And that's it. So yeah, we got about 4 minutes left. Once again, I encourage everyone to ask questions. So I showed you a little bit about, I showed you the code. I showed you the code running. I've got the link here, aka.ms/ACA on L4j. Showed you what it looked like in the portal, how the actual code works, and some of the results. Like I could go in and find that Hello World Java file in the portal as well. Hopefully that's useful. Check out aka.ms/ACA on L4j. I will update everything as discussed in the comments and that I mentioned here. So I believe there's a link there already to the LangChain4j examples tool. I'll make sure that I put the actual LangChain4j examples in there as well. There's still lots of PRs that I'm working on for this, so it's going to change. But the one thing that will remain constant is aka.ms/ACA on L4j. That'll be out there, and I'll make sure that you can see everything there. So got about 3 minutes left if anyone wants to ask any questions. Otherwise, we'll wrap it up. Hope it was useful for everyone. Thanks for thanks, saying very clear, easy to follow. Thank you. Yeah. Any suggestions on how I can make it clearer in the future as well, let me know. If you run into any problems, do provide some feedback to me. I'm at bbenz on all the social medias and on GitHub. You can just add comments or issues in the repo at ACA on L4j. Yeah, I should mention that is a repo. So aka.ms/ACA on L4j is a GitHub repo, and it's just for this session. And I'll have links to the slides are there as a PDF, and you can download and you can link directly to the code from there as well. And there will be changes. So if you're watching this later, definitely check out ACA on L4j for updates and changes. It'll be there.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.